Hey everyone. Welcome to a Machine Learning as Code, a year of democratizing ML with Kubernetes and Kubeflow. If you are not here for machine learning or Kubernetes or KubeCon or Kubeflow, well, I don't know what you're doing in this room, but you're going to get a whole hour of it, or 40 minutes. So, 1 year ago, 2 days ago, we introduced Kubeflow. And we really started with the question that you see here before you. Machine learning is everywhere. Everyone is talking about it. It's solving so many solutions today. But it's this vague concept. I do a bunch of math, I backport some weights, and magically all of a sudden I get answers. And that's really strange for so many people. Not just because it's this new advanced concept, but because they didn't know how to go about even doing the first step of implementing a machine learning solution. So at Google, we had this problem, and we came up with a definition. And the definition was, machine learning is a way of solving problems without explicitly knowing how to create the solution. When you take an enormous amount of data, and you label it, and you think about it deeply, and you're not really able to figure out exactly what's going on, that might be a space where machine learning can go through and process all this stuff and come up with a better answer for you. And at Google, we took this and it changed our entire company. The number of people, the number of groups and divisions who are using machine learning today is enormous. And this isn't just kind of like toy projects or next-gen projects. This is deeply wired into the way that we decided to start changing our business. In this case, I like to give this example around data centers. So at Google, obviously data centers are one of the largest expenses. Networking and electricity and cooling, these are the things that run every single query, every single YouTube video, every single Android query, every single Gmail query, costs an enormous amount of money. And we hire some of the best engineers to solve these problems. They know more about data center cooling than anyone in the world, arguably. And yet, we still were spending a lot of money on it. And the reality is that we looked at it and we were collecting so much data, we thought, could machine learning help solve this problem for us? What they did was they took all the data and they collected it and they wired it up to a bunch of different algorithms and pipelines and so on. And they went and they tried to see if they could improve things. And so here, they started measuring, and the measurement for data center efficiency is power usage effectiveness, the amount of power that goes in and the number of computational cycles that you're actually able to achieve. They went in, they turned on these machine learning models, and almost instantly, the cost for the machine learning, or the cost for those data centers went down, and the instant they turned it off, it went back up. And that's how dramatic it was. Again, the best data center engineers in the world, thinking about renewable, thinking about efficiency, thinking about cost savings, they got beat almost instantly by these machine learning algorithms. And what they found was, in many cases, it wasn't even decisions that they weren't sure how to do. It was stuff, it was many, many thousands of small decisions that these engineers were like, well, that can't possibly add up. But the machine learning system understood that it in fact could add up and did make a huge, huge difference. But the reality is that machine learning is hard. And it's not just hard because I'm bad at math. It's hard because there are so many components that you have to think about when it comes to machine learning. How do you roll out containers? How do you roll out new systems? How do you make upgrades? How do you build pipelines to connect all these systems together? And what we decided when we started Kubeflow was to think about containers and Kubernetes as the way to go about it. And the reason we thought about that is because of a big movement called cloud native applications. How do you break your complex monolithic application down into a series of small components that are loosely coupled together that understand how to scale up, how to move, how to be portable between environments? And so we thought, could we introduce cloud native ML? And cloud native ML looks like the following. When you think about ML today, most people or many people will say, well, it's all about building a model. Am I going to choose PyTorch or Chainer or TensorFlow? What am I going to choose? But the reality is it's not that. It's all of these components together. It's how do you get your data in? How do you transform it, validate it, do a distributed training run, build it, deploy it, roll it out to production, monitor it, log it. These are all independent microservices that many times you've already started to address via your move to cloud-native applications. And it's not just that. That's on just the infrastructure side. When you think about the end user side, deploying in Kubeflow, using Jupyter, using Docker images, training at scale, all these things, those are additionally areas where data scientists really don't want to think about all these other components. They really want to think about the underlying effort, the solution they're trying to come up with, and not really worry about the stuff under the hood. And when I say a complex stack of microservices, it's not just that top layer that I was pointing out there. It's everything under the hood. It's drivers, OSs, how do you do orchestration between nodes as they need upgrades, so on and so forth. And unfortunately, it's not just about one cloud either. The reality is that 81% of enterprises use multiple clouds today, and they don't just use multiple clouds or 2 clouds, they use up to 5. So you're now talking about a situation where you have your experimentation, and then you need to replicate that exact same stack in a new place when you do training, and then finally when you potentially move to the cloud or some highly scalable environment. And that's all the motivation behind why we decided to launch Kubeflow. That's me a year ago, slightly less gray hair, maybe, with Vish, the other co-founder, and then Jeremy Louis, who I saw in the audience somewhere. The 3 of us came together and founded Kubeflow a year ago at KubeCon Austin. And the reality is we wanted to make it easy for everyone to deploy, develop, deploy, and manage portable, distributed ML on Kubernetes. And so what that looks like is we make an assumption. And this assumption really changed the game. Instead of thinking about anything under the hood, we say, you know what, this is Kubernetes game. We're going to hand off. We're going to use the Kubernetes native constructs, Kubernetes native extensibility, and we're going to make Kubeflow an entire package on top of that. And because of that, you're able to take that Kubeflow deployment and roll it out into all of these different areas. So that's what we say when we say cloud native ML. In the past year, we have had tremendous momentum. Over 1,900 commits, hundreds of community contributors, 30 plus companies contributing, including a set of the people that you see there. And though it certainly started at Google, it is not remotely Google only. GitHub, LinkedIn, Intel, the Jupyter project, Red Hat, Selden, IBM. These are just a small set of people who have already contributed upstream and helped make Kubeflow a truly community-driven project. And by that, I mean the following. The reality is when you think about a very, very successful community, it'd be hard to do better than Kubernetes. And when Kubernetes first came out, and I know because I was there, people would like, oh, this is Google only, you know, you're going to somehow tweak it in some way that makes it only work on Google Cloud. And I would go out and I would say many, many times, nope, not us. We want this to be a community project. You tell us what we can do and we'll help you make it happen. And now, here you are, some 4 years later, this is what the world looks like, with every one of these colored slices being a different company. And for those that are curious, this is Google and this is not Google. And that's really, really positive sign. When you can say, when that line goes over the middle there, you're doing good things. That means more people not at Google work on Kubernetes and contribute upstream than the people who work at Google. So let's see, how's Kubeflow do? Well, this is what our chart looks like. And to make it simple, this is Google and this is not Google. And that's after 1 year. We couldn't be more ecstatic about this. And I want to make that orange pie as big as possible. We want to hear from you. We want to hear from the community about what we can do to make Kubeflow community-driven, solve real problems across the industry. To specify, and I want to call out, and this is just a small set of people because I don't have that long, we've gotten really significant contributions from non-Google to the overall platform. KTIB, it's a microservice-oriented architecture that Jay will be demonstrating just shortly for doing hyperparameter optimization. Really, really cool. And in Kubernetes in Kubeflow 0.3, we introduced a brand new higher level construct called a study job, meaning you can now do hyperparameter tuning without any coding whatsoever. And we'll demonstrate that in just a minute. Second, I want to call out TensorRT. This is a serving framework. If you were in the room 2 sessions ago, they gave a great deep analysis of it. And you can do all kinds of really advanced things, multiple models per GPU. You can support heterogeneous GPUs and things like that. And it integrates into those orchestration systems that use Kubernetes under the hood. A third one, we've had a workflow engine, built into Kubeflow. For over 12 months at this point. We introduced it at the beginning of the year. This is from Argo, and you have workflow, you have engines and pipelines, and we'll show more about this in a minute. We also have Argo CD for using ML GitOps, where you're able to make changes in code, push that into your GitHub repository, and have that cascade through and make changes all the way down your ML pipeline. And again, I know I don't have an enormous amount of time. This is still, like, even with all these slides, I'm still not even covering it. I do want to call out some great work from Aricto, Red Hat, and Intel around a Jupyter spawner. So now in a Jupyter notebook, you're able to spin up all the necessary dependencies, persistent volumes, and so on from that Kubernetes underlying engine. Selden has a very rich serving framework for non-TensorFlow models, and they have built both a commercial and an open source offering. And KubeBench from Cisco, who does ML benchmarking on top of Kubernetes and Kubeflow, and makes it very easy to explore if your deployment is operating at its top performance. So with that, introducing Kubeflow 0.4, almost. It's coming out next week. And the reality is here, we've heard from the community that one of the most challenging things with Kubeflow today is that it is still too hard to use. We surface a lot of things around templating and deployments and things like that that really, as a data scientist or an ML engineer, you shouldn't care about. So we've made some big improvements around deployment with both a simplified setup and an application CRD. And then also we've made big improvements with one of the biggest announcements in the entire year around Kubeflow pipelines, which gives you a Python-based way to engage with Kubeflow, and we'll give you a deep demonstration there, as well as TF job and PyTorch reading, in Kubeflow reaching beta. And with that, let me hand off to Jay to show you some of this goodness.
Thank you very much, David. So we have a lot of fun things to show you today regarding Kubeflow. One is click to deploy. Common thing we hear is it's too hard to install Kubeflow. I don't want to have to deal with the command line. I don't want to have to figure out how to install case on it, deploy a case on it app. Solution, a one-click installation tool available via a clean web interface. How did we do that? Well, we created the click to deploy, which uses a bootstrap container and the kfctl.shell, which is something that you can run on your own infrastructure. Which worth pointing out, it will install Kubeflow for you pretty automagically, as some of us would like to say. It also enables use of declarative infrastructure deployment. On GCP, we call that the deployment manager. And there is no templating tool needed. But you know what? Let's show instead rather than tell. Bear with me 1 minute. All right. So this is what it would look like. And one thing I want to call out real quickly is that while this is a web interface that is for Google Cloud Platform, the underlying tools such as the KFCTL can be run on any environment. It's not just a Google thing. Though this web interface is today. As you can see, we only take 6 inputs: project name, the name of your deployment. There's a web app client ID and a client secret. You can get it. We give you detailed instructions on how to acquire those. You also have a zone that you will set. And the Kubeflow version, for this example, we will be deploying 0.3.2. So when you click it, it'll start running. You'll get this output here. Oh, deployment's done. Let's see what happens. And let's see. Let's jump over. All right, so jump back a little bit. All right, so here's our deployment. Let's take a look. Oh, wait, there's no workloads yet. Okay, maybe it's still building a little bit. Still building, still building. Let's refresh. Well, look at there. We have everything that is bundled within Kubeflow that you used to have to do a lot of templating with KSON, deploying the KSON application, a lot of manual work, all done with 6 parameters in a web interface. So now we have it deployed, and then again with the KFCTL, you can also deploy this on-prem on another cloud provider. In the spirit of open source, we don't force you to stick to just Google Cloud. But once you have deployed it, what happens when you want to upgrade? I mean, we just talked about 0.4, which is coming out next week, and you say, well, I just deployed 0.3. How do I upgrade it? This was great to install, but, well, we're looking at GitOps. How do you maintain the cluster? Maintaining a cluster can be hard. We've implemented GitOps, which I should point out was a term coined by Weaveworks, a GitOps-driven solution to manage infrastructure and the cluster code. We are using Argo CD. And they actually have a pretty cool demo downstairs if you haven't taken the time to stop by the booth. Synchronize the Kubeflow deployment with a Git repository. And we have a blog post that shows you exactly how to do that. If you go to, or rather our documentation, if you go there, you can follow the instructions and do that just as well. Now, one thing we just announced and that David talked about was Kubeflow pipelines. The problem? ML solutions are often multi-stage. Anybody here do anything with ML models? Yeah, so anybody here will agree with me that they're often multi-part. They're not just one thing. So the solution was to leverage microservices, leverage containers, make each stage its own container, to enable reusable components and workflow orchestration. So Kubeflow pipelines, it's a Python SDK that allows you to describe and containerize the different tasks. It runs on Argo and offers experiment logging and analytics. And each step is containerized and lets you extend it as needed. It takes advantage of this concept of microservices, of these very separate, segregated services that are specialized in an area, so you can make modifications to one without directly affecting the other. Again, let's take a good look at how it works. So here we're in a shell. We are going to, do I have it playing? Yes, so we're going to go ahead and take a look at the Python code. Now this is standard Python. Anybody here who knows Python can read this, and it will show you exactly how to define the workflow. Each step here is a container. Let's go ahead and package it by executing the pipeline, the Python code there. And now it's going to create a YAML. So we do like to provide a lot of examples in Kubeflow to kind of give you an idea of how things can work, how things can be used. Examples are very beneficial in learning. So we're going to take a look at this taxi tip example here. Now you can see these different steps here, these different squares. Each one is a container, each one is a process. If we go ahead and click on any one of them, we will see that it has input parameters, output parameters. You'll see that each one has slightly different ones because they're, again, each stage has its own container. They're their own separate process. And why don't we go ahead and upload the YAML we just created. So let's click Upload Pipeline. And we'll choose the file. There we got pipeline.yaml there. And oh, there you go. Simple as that. And now we have 2 stages, training and post-processing. Each stage is its own container. We have input-output parameters. And just like that, you're able to create a multi-stage pipeline. Very minimal code. You created Python code, generated a YAML, uploaded it, you're good to go. So let's go ahead and start an experiment. We're going to name it pipeline, keep things simple. Then we're going to run the pipeline. And we have 2 layers, learning rate of 0.1. And there we go. Now here's a good place to stop. Let's talk about another feature we have here. Autoscaling. Now here we have a conversation going on between a data scientist and IT ops. Tell me now if anybody recognizes this as we go forward. Model works great, but I need 6 nodes. Sure thing. Can I get to it after, the 100 things I have to do today? All right, well, when you have time. Time passes, time passes, time passes. Oh, IT ops eventually gets to it. Great, we have 6 nodes. Maybe this was a day later, a week later, who knows? We're happy, that was a lot of work. All right, we're done, let's go ahead and deploy. Okay, we're deployed, we've trained, let's just leave it. Oh, I forgot to turn it off. Well, I think somebody in finance is not going to be happy with us. This is a very common thing. So we introduced autoscaling. So you can describe the job, and Kubernetes will take care of the rest. So you describe how much CPU you'll need, how much RAM you'll need, accelerators, GPUs, TPUs. TF jobs will then delete themselves when they're finished. So the node pool will automatically scale back. And you can cap it to a maximum parameter, so that way it doesn't scale to an infinity, and then your bill scales to infinity. So let's see what this looks like now that we have autoscaling. Model works great, but I need 6 nodes. All right, so I create a simple definition here. We got some 6 nodes, job's done. Oh, I guess we gave IT some time to look up cat videos, great. Let's see this in action, why don't we? Let's jump back to our video here. Refresh. Huh, job didn't run. Wonder what's wrong. Let's take a look. All right, so we have 3 nodes. Let's take a look at the workloads. Oh, wait, my GPU, it's unschedulable. What's happening? 3 nodes are available. Oh, insufficient GPU power, that's not good. Let's go back to the cluster, see what's going on. Let's take a look at some of the nodes. Okay, so wait, we have 4 nodes now. 1 just came up, it's not available yet. All right, let's refresh, see what's happening here. And as you can see, the nodes is being prepared. It's now in this not ready state, but it went from red to yellow. And now that we refresh again, oh, that 4th node is ready with the GPUs that we need to run. So when we go and refresh the code, there we go, it ran. Simple as that, it scaled up to what it needed to do, or it scaled up to the resources that it needs so that it could do what it needed to do, which is a good thing, and it will scale down when it's done. Pretty interesting, isn't it? Being able to scale up to the resource you need for training, then scale back down. I mean, this is the beauty of cloud native. This is the beauty of the cloud. This is the beauty of Kubeflow, being able to use resources when they are needed, but then not having to have them perpetually and eating that cost. So we talked a little bit about cattib, which does the hyperparameter tuning. It uses a feature called study job. So let's go ahead and take a quick look at that. And let's see here. Oh, here we go. So we're going to go ahead and apply this example file to build out the nodes that we need in the job. So now we're going to get the study job. Okay, there we go. Let's take a look and describe it. Okay. So this looks pretty standard for anybody who's used Kubernetes. It's given us all the information, so let's scroll up a little bit. Okay, so we're using, let's see, we were going to have a learning rate of about, let's see, we got 0.01, 0.2, then we have, scrolling down a little bit. Okay, here's our pod. All right, so the pod's being built, and now we will go ahead and see, oh, wait, So we're seeing the exact same thing we saw before, though, but it's in process of being created. Get the nodes. Look at there. We have 3 nodes ready to go for the hyperparameter tuning. Hyperparameter tuning simply will spin up multiple experiments simultaneously to do your testing. So in order to spin up multiple experiments, we need a lot more resources. And here is what Katib gives us. So we have the learning, correct, we have the learning rates here. We have some model IDs. And with this visualization, it gives you a great graphic, if you will, that will tell you, well, that's exactly what it is, a graphic that will give you the visualization of all those simultaneous models that are running, all that simultaneous training that is going on. And why don't we skip ahead? Yeah, there we go. So you also have this option here where you get another graph. You can also create some visualizations. We all like sharing graphs, don't we? You can compare some information. We have the different optimizers. We have SGD, FTRO. Let's go ahead and take a look at some hyperparameters here. Let's look at model number 5. Let's look at the hyperparameter. All right. Let's collect that optimizer. Let's filter for it. Let's go back to the chart. All right, accuracy. That accuracy looks pretty good. So let's group by number of layers. So what you're seeing here is you have this graph powered by Katib, and I keep wanting to call it Katib, but Katib. Let's go ahead and ModelDB. Let's go ahead and create another pipeline. We'll just clone the exact one that we had before. This time we're going to change the learning rate. We're going to add a layer. We're going to change the optimizer. We're going to create it. It's going to go through that same process. It's going to run faster now, though, because we do have those extra 3 nodes that we created earlier. We're going through the training process. Let's look at some logs. And we refresh, All right, training's done, post-processing. And we have training accuracy at 0.99. Spin up the cluster again. Let's take a look. Oh, training's done, and notice that those nodes are gone. Wasn't that great? We were able to do hyperparameter tuning, spin up 3 nodes so that we can run those multiple models simultaneously. And then once it was done, those nodes are gone. I don't have to pay for them anymore. I just paid for it in that short time that it was around. And I want to add that a lot of this stuff was built because of the community. Pipelines is built on top of Argo, for example. Well, so now we showed you some of these pretty interesting features. Let's talk a little bit about the roadmap. Let's talk about the future of Kubeflow. We talked about where we've been. Let's talk about where we're going. So we are continually improving enterprise readiness. While we do see some people using this in a semi-production type environment, we always want to improve it so that it will be more ready for the enterprise. So cleaner upgrades, RBAC compatibility, so on and so forth. We're inching closer to version 1.0. Better Jupyter Notebook integration. We want to include pipeline experiment comparison and model management. But of course, one thing that we always believe in the world of open source is sometimes the best feature is the one that we haven't heard of and the one that you tell us about. So you can tell us what you want, or you can help. We can always use more coders. We can always use more ingenious ideas, if you will. And it's a whole new world. We talked earlier about how machine learning is becoming a thing, data science is increasing, and data science is starting to touch every industry, whether it is I'm searching on Google for a pizza place in a new city, or Netflix is telling me what videos I might like based on the videos I bought before, Amazon's telling me what products I purchased before. Data science is starting to expand. And we can't ask people to become a PhD in statistics. However, we can we do have to ask ourselves, how can we help people enter into this brave new world? And if we can simplify the process of getting started and of building out this layer, take care of all of that busy work, if you will, of scaling out resources, acquiring servers, putting servers into racks, whatever the case might be, we are able to better provide this environment for people to start entering the data science field and help people who are already in the data science field. Kubeflow is open. We have an open community. We open design, open source, open to ideas. So maybe you're asking yourself right now, well, how do I partake? How do I actually help Kubeflow? Well, kubeflow.org. Fork us on GitHub. Check us out on Slack. Hit us up on Twitter. Talk to us while we're here. We have quite a few people in the room who are representing the Kubeflow community. We have people downstairs in the Expo Center. So there are many ways for you to get involved. And I guess with that, we can open it up to some questions, if anybody has any. Yes?
Are you guys thinking of Jupyter Lab extensions to kind of control Kubeflow?
Yeah, absolutely. So the question was, are we thinking about Jupyter Lab extensions to think about controlling Kubeflow? Absolutely. That's probably one of the top requests that we have. Data scientists obviously know Jupyter really, really well, and we want to deeply integrate that under the hood. Honestly, it required pipelines landing, which just landed at the beginning of November in order to do that, because oftentimes a very standard path would be, okay, I've completed my notebook, click a button, take that notebook, package it into a distributed container, and then run it as a distributed job. Those are pipeline steps. And so in order for us to do that, we needed pipelines to land. Now that pipelines has landed, that's probably one of the top requests we had, and we are very deeply thinking about that. Absolutely. Yeah?
How about the model hosting service and, let's say, integration, maybe things like Knative or maybe other like GPU serving?
The question was, how about a model hosting service as well as integration into Knative and other solutions? Can you say more about what you mean by a model hosting, like experiment tracking over time or external?
Yeah, external, like
Yeah.
hosting,
Yeah, so that's one of the reasons we built on Kubernetes and had this microservices first architecture. You saw all those blue boxes up there with all those arrows between it. Not everything will run in Kubeflow. I guarantee it. Whether or not it's your data, whether or not it's your storage, whether or not it's your serving, everybody who is doing ML today is piecing together services from across the board. And because we built on Kubernetes and because it is a microservices first architecture, it doesn't matter. A pipeline step can call something inside of Kubeflow running on the same Kubernetes deployment. It could be calling a second Kubernetes deployment. It could be calling a software as a service API. Doesn't matter. As long as that service knows how to receive a webhook and then hand back to pipelines an event, we're good. And pipelines is very rich when it comes to that. Simultaneously, you asked about Knative. Again, same deal applies. Think of Knative as just the underlying runtime for executing an arbitrary stage. There's absolutely nothing you saw here that requires a full node or requires anything of that kind. You could very trivially say, oh, okay, I'm going to hand it to this. I'm going to hand this container to Knative under the hood and go to town. We don't have that integration yet, but we're absolutely talking to that team. Any other questions?
Oh, here.
Kind of following up on that.
Yeah.
Between all these steps, the model metadata and performance numbers, where is that stored?
So that's actually the follow-up question was, where's the model metadata stored? Experiment tracking is a thing that we're trying to sort out right now. We would love engagement from the community. You saw there that, for example, Katib will track all the different hyperparameter searches and things like that and give you results. We are actively talking about that, and it is something we would very much like community feedback about what the right solution is there. We haven't seen anything yet that is exactly the right fit for the way Kubernetes works, but that's not to say we're not open, and we're happy to kind of like land wherever that goes. To be clear, pipelines, as you saw, offers the ability to track multiple pipelines over time, And we're planning to make that much richer, but we want to make sure that we're balancing everything properly. So please come in and give us your feedback. Yeah.
So I don't know if you're familiar with the Acumus project. It's a Linux Foundation machine learning collaboration.
Yep.
Project. We will be incorporating Kubeflow into our current release.
Oh, that's amazing.
Yeah, and one of the things I'm working on at the very beginning, you said it's sometimes been difficult for people to install, like KSonnet, et cetera.
Yep.
One of the things I'm developing and is ready if anybody wants to use it is a one-click encrypted way to install Kubeflow and the client.
That's amazing. That is amazing. So this gentleman over here said that the Acumus project, which is the Linux Foundation deep learning project, will be integrating Kubeflow and having a solution come shortly. Please do check in with the KFCTL folks and the Bootstrap container folks, just to see, because there may be tools that you can reuse as it stands right now. What you describe is awesome. It should be very, very thin, the amount of work that you have to do.
It wasn't hard.
Okay, great.
And with 3.4, it got really, it's actually Kubeflow on OpenShift.
Oh, that's great. That's amazing.
Okay, I think we're at time.
Any other questions? Yeah.
How does this work with multiple users?
The question was, how does this work with multiple users? Multi-tenancy is something that we're trying to sort through right now, to be perfectly frank. What you see integrated into Kubeflow today is Jupyter Hub, which does have the concept of multiple users. It depends on your level of multi-tenancy requirements in order to get things going. Given how early this is, and given the low resource requirements of a kind of resting Kubeflow deployment, probably what I would recommend today is multiple clusters. But again, that's largely dependent on how hard it is for you to set up a cluster and things like that. Most clouds, obviously, it's one click away, and then you just hit a deployment. But the reality is we have heard many, many times like, look, I just want to set up one Kubeflow. I want to have a web-based API that understands the identity of my users and things like that and lets them each share and build and things like that. I wish I could say we had a rich solution for that, but please come to the community, tell us your requirements, and I promise if it's not already on the backlog, we'd love to add it. We are out of time, but thank you very much, everyone, and thank you.
We'll be around, so.
Yeah, I'll be up here and outside if you need me.